Good morning, everyone. Thanks for coming. It's the last session of the day, so appreciate you actually coming and attending. We'll do our best to get you where you need to go afterwards at a good time. I'm Kevin Gavsky. I'm a product lead of our data fabric capabilities in the platform. I'm here with Daniel. Daniel is one of the product managers on our team. He leads the back end of our data fabric. We have some content that we'll go over, but we also want to make this interactive and leave as much time as we can for questions. So we'll kind of speed through some content and then, definitely want to just kind of talk and hear what questions you have. So before we get started, I want to get to know you a little bit and your journey with Appian and our functionality. Can you raise your hand if you're using sync record types? Great, primarily in your applications. Can you raise your hand if you use some sync record types, but also have some legacy applications, CDTs? Okay, cool. Anyone not using any of the new data fabric features?
I have some old applications.
Some old applications, okay. Anyone else haven't had a chance to use any of them? Okay, it's a little bit more of an experienced group. That's great. Anyone here relatively new to Appian and not sure what they're doing with data? Okay, great. Awesome. Well, we're going to talk a little bit about how you can use data fabric in existing applications. So a lot of people ask us how to get started. So we'll talk a bit about that, and then we're going to transition to some best practices on data fabric design and queries. So I'll start with a quick intro, and then talk about places where we think you can use the capabilities, and then kick it over to Daniel for some best practices. We set out to build our data fabric capabilities to make it easier to leverage data in your applications. That was the biggest thing, right? Like, it was before data fabric was even a term that we knew of. We were trying to, like we do for everything else on the platform, make software development concepts more simple. So we wanted to make it easier to connect to data and leverage that data in your applications. And the benefit then would be your applications would be faster to build, and they would perform better because, dealing with data, there comes with a lot of performance considerations. So that was really the start of why we even embarked on this investment in engineering. Over time, we've also added self-service analytics capabilities onto it too. So now you have the ability to access your data and get insights on top of it on the platform. So you've seen a diagram like this probably a lot, but what is our data fabric? Well, it lets you connect to data in the different source systems that you have across your enterprise. We can model data relationships across that data, regardless of what application it lives in or system. And then we sort of make this virtualized data model of all those entities that you can leverage to build your apps more quickly. And then once you have that data model, right, you can build UIs that are sourced from multiple systems very easily with our no-code design experience. You can leverage that data in your workflows. And RPA bots can leverage them, your AI agents can leverage them, and you can get out-of-the-box reporting on top of it as well. And yes, I'm going to give a little pitch for AI. It also now, a lot of our AI features can leverage the data model that you set up through our data fabric. We're at the point where most of our customers are using these features in their production applications, and it's kind of like a mix like we saw in the audience. Many of our newer customers, all of their apps are based on sync records, but more commonly what we see is our existing customers have this kind of mix of I've started to use it in some places, or I'm trying to figure out where to use it more. So that's why I want to spend some time today talking about that. When should you use our data fabric capabilities? When we talk about data fabric, it really is kind of all of our data integration features when we kind of talk about it at a high level. But when we think about the capabilities we've been releasing in the last 5 years, it's really all tied to sync record types, or most of it is tied to sync record types. So when should you use it? Trick question. You should try to use it always in your new applications. Now, there are reasons why you might not be able to sync your data. There might be data recency requirements. There might be IT policy restrictions. There might be legal requirements, right? Those are some reasons. And then there might be scale, right? But over the Appian releases, we're kind of removing different barriers to why you wouldn't be able to leverage that. In existing applications, it's definitely a lot more nuanced. So what we usually try to say is, okay, if you have an existing application that's built on the old sort of data stack, CDTs, data store entities, what we like to say is, okay, well, you can first start by creating mirror record types of the data that you've already configured as CDTs, and then you can kind of leverage that just for our out-of-the-box capabilities, right? As soon as you get that sync record type, you could start using Data Fabric Insights to report on that, expose that to your end users. Some of our new AI capabilities don't need more than the record types configured either, right? So if you wanted to chat with the data, you can just set up kind of mirrored sync record types to the existing data, and there you can start to get some value before you even go and refactor an application. That's usually kind of like the first step, we say, and then we start looking at targeting specific places in the application. This is sort of a little bit more about where you can target these specific capabilities, right? So I mentioned Data Fabric Insights. It's our self-service analytics capability in Process HQ. AI Copilot and Smart Search are two new AI features that leverage Data Fabric that you could start using and embed in different parts of your application without having to make a big change to your app. And then when you're building out net new UIs in an existing application, you could start to use sync records there, right, to benefit from faster design and better performance. And then data sync is something that Daniel will talk a bit more about, but that is the way that we're then able to do things like record relationships across multiple sources, add custom calculations via custom record fields, and that way you can kind of extend your data models in the places where it makes sense. When I'm looking at an existing application and we want to start converting to using sync record types, there's a couple places that we usually ask folks to take a look at first, right? A common one is maybe I have a UI, it's calling a external system on it, right? Because you're doing a live call, you're adding seconds to your UI loading time. What we could do is use that as a place to target an improvement, right? And let me switch that to be a sync record type. So now that can be a local query instead of an external system call. That might not work for everyone's use case, but that's one example, right? So targeting places like where can I maybe look to improve performance on the UI? Another thing is because we have all these no-code components that are based off of Data Fabric, you could pretty easily build your own dashboards or something, right? So if you have an existing application, like a case management application, and your users want some sort of reporting capability, well, you could make another UI that is backed by these sync records to then embed that in your application. That's separate from Process HQ, which is the self-service kind of reporting, but you can make a kind of custom report that you build in your UIs. And the last thing is you might already be doing some of this data syncing or data movement in your applications today via process models, right? You might be calling an integration or whatever and bringing in some data from some other system and then putting it into the Appian database. Well, our data sync technology can kind of replace the need for some of those. So that's a place where you can revisit. If you're doing that in some of your older applications, we might have out-of-the-box features for that. This is sort of what we describe the older data stack to look like, right? You've got your source system, the data store object, CDTs, and that's what you leverage in your applications. So what you can do when you start to switch over to using sync record types, this is where I mentioned that mirrored record type. You could create this orders record type on the right. And what happens is now your existing application that's managing the data updates through the CDTs is going to make sure that all those updates are also auto-synced to that record type. So you could start querying, now you have this other read-only version of the record type, of the orders data, but it's in the record type object. Okay, so why would I do that? Well, the reason why you do that is then automatically now that thing could be exposed in Process HQ or to our AI features. You don't really have to do any other all you do is create the record type. It takes 3 minutes to go create a record type of that existing table. And then over time, what you can do is start incorporating that record type into the different components of your application, interfaces, or net new interfaces. All right, I'm going to kick it over to Daniel to talk a bit about different best practices for design and querying, and then we should have plenty of time for questions to keep going. So
Definitely.
Thank you.
All right, thank you, Kevin. Kevin just talked about what data fabric is, why you should use it, when to use it. I'm going to talk about really how you should use it, and mainly what I want to get into is how to build performant and scalable applications and make sure that your applications are sort of future-proofed. And so there's two kind of categories of best practices that we'll get into. One is syncing what you need, and two is going to be querying what you need. So this is going to be important for kind of guiding you on how to build lightweight, efficient applications that are managing your operational data. Let's jump into it. I'm going to start on the sync side. So when you're creating your synced record types, you'll see a screen that I kind of merged two screenshots, but it's going to look something like this. And you're going to have something called sync filters on the side where you can add a filter to basically get a sliver of the operational data that you want to sync into your record type. So if you have a table and for some compliance reason you have to keep historical data around for 7 years and your table's millions of rows, you don't need to sync all millions of rows if only the active data with an active status is relevant to it. So here I have an example where you can see the filter is on the completed field of this order record type. So I'm syncing all of the orders that are not yet completed into my application. So this is one way to kind of reduce down the amount of data that you're syncing over and just make sure your sync operations are lightweight and efficient. Building off that, recently we released a feature that allows you to sync based off of related data. And so this has been a common ask. And the way that it helps you is if let's say I have customers and I have active customers that I synced using that base record sync filter that I showed in the previous slide. Now in my orders table, I probably don't need all orders for all customers historically. I want the orders, but I want them all related to active customers that I synced. And so this allows you to specify the relationship that you want to sync based off of. So now this orders table is going to be syncing just the orders that have active customers. So that's a new feature that was released, I believe, in 24.4. And if you haven't started using it, I highly recommend it. It's really helpful if you have one-to-many relationships, kind of reducing down that many side, which is generally going to be where the most volume of data is coming from in your applications. And kind of piggybacking off of high-volume data sets, another pattern that you can explore is actually syncing multiple record types from the same source database table. Kevin talked about some of the auto-syncing capabilities. That actually applies to this as well. If you have multiple record types pointing to the same source table, we take care of behind the scenes making sure that all of the updates are applied appropriately to each synced record type. Really the only trade-off that you should be aware of is, one, there can be some complexity in your application depending on your governance and your record level security rules that you might need to apply to each of these. So there's application-specific nuances that you'll want to be considerate of. And then two would be, for each of those sync operations, there is some computational overhead on the back end. So your write to records nodes, your write to data store entity nodes may have a little bit of added overhead on the performance side there. So it is a trade-off that you can consider, something to be aware of. But this is really, really great for when you have record types that exceed the row limit. You want to reduce those down. We've also seen customers have success syncing to, like maybe you want your active orders and you still want to sync your historical orders, you just don't want to have to query through all of your historical orders every time you query that table. Then you can sync them both and just use the active orders for their primary core operations, and maybe your historical orders are used for audit use cases or something like that. This would be an example where I have an order table that I'm syncing one active order record type that has the completed flag set to false, and then one completed order record type where the completed field is set to true. All right, so moving on from sync filters, these are some sync options that will help you build more reliable syncs and ensure that you're spending less time worrying about any failures that might happen. Now with this said, smart service syncs are generally very reliable. We see across all of cloud sites 99.999% success rate for smart service syncs. But in that 0.001%, you still want to take care of some edge cases. So there's a few options that we have that you can find in the checkbox with checkboxes in the record designer. Super easy to configure. The first one is keeping data available at high volumes. So if you have a record type that's pushing up on the row limit, you can set this, and if you get to the row limit, there's some buffer room that you can grow into, but also we will filter it down based off of the last modified date. so that you have access to all the most recent and relevant data in that record type. So this is a really easy configuration to set to make sure your data is staying active and your record type is staying up, your application is up when you're operating at high volumes. Another flag that we have is skipping failed syncs. So what this allows is for you to keep your record type active and operational even if a sync fails. This is specifically referring to full and incremental syncs. I'll talk about incremental sync in a second. But yeah, so this is going to take care of cases where maybe you have a flaky connection to the system you're syncing from. That might be why you want to sync in the first place. If you can skip the failed sync, what it's going to do is let your data stay operational, and at the next sync, it'll resync that data. So your data won't refresh immediately, but that won't take your record type down or anything like that. So this is another way to make your sync record types more resilient. Highly recommend using this flag in most cases, really.
Sorry, Steve, is there any time we might not want to use it? Uncheck.
There might be cases where you've made some guarantee to your business users that the data is within 24 hours up to date or something like that. And then maybe you wouldn't, but generally, I mean, I would say no, I certainly will not be removing that checkbox. And the last option here is going to be recovery syncs. This is another newer feature that I believe we also released in 24.4. The recovery syncs are for smart service syncs, and they're also going to be for incremental syncs, which I'll talk about in a second. But this will allow you to, in that 0.001% chance that your smart service sync fails, maybe it is also because of a flaky network connection to your source system, we will resync the record type automatically so that you don't have to go back into your application to remediate anything. So this is going to save headache, save troubleshooting after failures, and make your record type more resilient. So all sync options can be used at the same time. So definitely go in, and if you haven't checked those for your sync record types already, consider doing that to save some headaches. All right, and probably the most exciting thing, so in 25.2, we'll be introducing a new best practice and feature with incremental sync. This is going to really change the way that we sync data in most cases. Generally, we should be syncing only what's changed. Syncing everything every time is not as efficient as only syncing the latest changes, and so this is what we want you to do. We're offering it first for HTTP and JDBC-backed sources. These are really where there's the most complexity in terms of getting records synced, and so this is going to be a really high-value way to improve your sync options for web services and JDBC sources.
When you say JDBC sources, you're talking about through the JDBC, right? Not through the JDBC connectivity object or integration object. You can't right now use that as a source, right?
So there's a generic JDBC connected system that we released last year, and that is what we're referring to. Yep. Yeah. So in your SQL,
through an integration, so it's like a service back record type.
Yep.
Yeah,
essentially.
Before it was, you couldn't use
Yep.
like the JDBC connectivity as a.
Yeah.
You can use any of the JDB sources, right?
Mm-hmm.
In the console.
Yeah, so in your SQL integration, you can define the filter for last modified timestamp. I have a demo for the HTTP backed in a second, and so we'll show that. But one thing I do want to add on here is, in addition to these sources, we do have plans for later in 2025 introducing this for database back record types as well. So at that point,
For the GIND, yeah,
Yep.
like you were saying.
Yep. So at that
There's more security put on the connection object versus the wide open JDB. Yeah.
Yep, absolutely. So yeah, at that point, really all of your synced record types, as long as the source can accept a last modified date field, we'll be able to sync just the change data. It's going to have our sync operations running a lot more lightweight without having to run full scheduled syncs every night. So with that, let's take a look at a quick demo. So here you can see I'll be able to move to using a scheduled incremental sync in just a few minutes. I can check this box, and that's going to pop down some configurations. The first one is going to be the last modified field. So I just tell them what the field in my record type is that has that data, and that's going to be what I use to pass into the integration object. So here I need to configure a sync expression and integration. I'm going to use an existing integration that I already have. It's called get orders, get updated orders. So we'll click that, then move on to configuring. So here we're defining an expression rule, and we need to tell them what our paging logic is going to be. I'm going to choose batching by sequential values. I can open this automatically generated expression now, and when I open this expression, it's going to have a couple rule inputs. If you've ever configured a web service back record type, it has this batch number, which you can plug into this this field that gets passed to the integration object. It's also going to have a new thing called last successful sync. That's going to tell the integration the last time a incremental sync succeeded, so when to sync the data from. Now I have these parameters in my API call that I can pass in, and I can save that, and my incremental sync expression is configured. Now all that's left is taking a look at these other sync options. You can see here we have sync changes every. We have a lot of options there that will open a second, but you can sync any interval from 15 minutes to a day. So that's going to give you a lot more flexibility in how often you refresh your data. All right, so I'm going to move on now. We're going to talk a little bit about query best practices now. And when we talk about query best practices, this is where we're really trying to ensure that the patterns that you put in place will stand the test of time. As your applications exist, data generally grows. And so we talked about the sync options that help you kind of keep the operational data at bay and make sure you're syncing the data that's relevant to your application. In addition to that, complexity generally grows as well. As an application goes on, it doesn't have less functionality. Generally, business users want more and more information in their interfaces, functionality, buttons to click on, fields to look at. And as you add more fields, as you add custom fields, new reports, new types of aggregations, the performance needs to stand the test of time. So that's what we're going to really focus on here. The first kind of principle is going to be to select what you need. And here we're talking specifically about the fields that you need. So general database best practice is going to be to select the fields that you're actually using in your interface and processes. This is really important to keep in mind when using Appian because there are places where it's really easy to just fetch everything. And that might be convenient when you're prototyping, but when you're building a performance-sensitive, high-scale application, you need to be very aware of the fields you're selecting. So here, I'm going to be talking about a few different ways to do that. One thing I want to drive home here is that each field adds a little bit of execution overhead. And there's kind of two ways. One, in terms of data transfer between components and interfaces, and then two is going to be in terms of computational overhead in the underlying data system that's executing the queries. So one case where you might select too many fields is if you're using relationship lozenges in query record types. So you have these auto select capabilities, and if you select the relationship, it's very convenient to say, just give me all the sales order header details because that's what I want to display information from. What this is going to do is by default select every field on that record type. But we don't necessarily know what is on that record type. There could be complex custom fields. There could be complex custom fields talking to related record types. Those related record types could have complex record level security rules. And so being aware of what you're selecting here is critically important. And in addition, this pattern doesn't stand the test of time because if that record type data model changes, if fields are added, if new security rules are added, we don't know how the performance is going to change. So by using explicit field selections, we're taking a little extra time up front to make it so that we're confident in the performance of the thing we're configuring, the query we're configuring, and that it's going to stand the test of time. So that's one way. Another way is in our record views. So the RV-bang record function, which if you've used synced record types a decent amount, you're probably familiar with. This is for if you have a record grid, you can click a link, and that'll take you to a summary view of your record type. And it's really easy to populate that through this RV-bang record, as you can see on the left. What this does is relies on Appian implicitly figuring out which fields you need for that interface. And the way that that logic happens is really complicated if your interface is very complicated. We'll parse through the expressions and nested interfaces to try and find every field that you need to reference. And at times, it can cause confusion for developers. They don't know why there are so many fields being selected. So to kind of get that 100% confidence in the performance of your record view and that the record view is selecting exactly what you want it to select, you can use a query record by identifier there. Again, you're taking a little bit of extra time up front, but this is going to give you the confidence you need to know that when a developer goes in, maybe it's someone else that's going to change these fields on this record type, that your query is going to perform the same. Another case is in grids. So the same sort of auto selection behavior applies to record grids as well. And so in your grids, where you're defining your record data, you can, in the same way, define your fields explicitly. And again, this is going to make sure that you know that this grid is selecting exactly the fields that you need and that you specified to populate it. So taking a little time up front, making the application more future-proofed from a performance standpoint. All right, and the next thing is a new tool that we introduced last year. It's called the Query Performance Monitor. This is something if you haven't used yet and you're trying to figure out how to figure out performance with sync record types, this is really the best place to start. You can enable this in any environment and you get a bunch of information. Every single query that runs through your site is going to be logged here. And the permissions that apply to those queries are going to be applied. So if you have access to a record type, you'll be able to see the queries that are running there. All of the PII is scrubbed out, so there's no worries about sensitive data. And what you can see is execution times, the raw execution time of the query that you issued. You can see who executed it. You can see the wait time. The wait time refers to if there's any contention for query resources. If you sort by wait time and you see times throughout the day where wait time is in the seconds, you'll know that perhaps my environment isn't appropriately sized, and you can have that conversation with your support team. So there's a lot of information that you can glean from here. One thing that I'll call out explicitly too is that you can actually see the exact definition of the query that gets produced. So when you're using RV-Bang record or using a grid, we will put it in terms of query record type and show you exactly what's being queried. You'll notice that that filter also has that value scrubbed. So we're not going to show you the exact value that was there because that could contain sensitive data, but we will show you what the definition of the query is and give you some more clarity into your site. Another thing we offer is a bunch of filters. So you have filter options for evaluation IDs. I'll talk about that in a second. You can filter by different time ranges, different execution times. So maybe you're just looking for the slow ones. And then component, which would be like a grid or a query record type or a chart. The most important ones that I think people generally point to are, I want to figure out why a particular interface is slow, or why a particular expression or record type in general is slow. And so you can add those filters there, and what that'll do is just filter down the data set to show you exactly what you're looking for. And then further, the evaluation ID refers to the SAIL evaluation. So if you're using this query within an interface, that evaluation ID will show you every other query that ran as part of that interface evaluation. So now I can see for my transform orders, this is a bad example because I only have one per execution, but I could see if I had maybe a dozen queries running as part of a single evaluation. And that would indicate that perhaps I've configured too many queries to run at the same time that are prerequisite to loading this interface. And so there's a lot of flexibility in terms of how you can figure out what the root cause of a performance issue is in your application. And the last thing, which is extremely important, is that we have a connected environments feature that allows you to monitor any environment. So from dev, I can monitor prod if I have access. There's no PII in it. And so what this requires is that you enable the query performance monitor in your production site. You can do that for a period of time. You can leave it on. There's generally not much of a downside to doing this. There is a little bit of disk usage to log those queries, but generally speaking, this is going to give you the best insight into your production environment. And that disk usage is going to be temporary as we churn through the logs over time. So yeah, with that, I think that is my last slide. Our call to action is to start using sync record types where you can. Start small, really optimize that time to value ratio. We know you guys have a very limited amount of time to spend picking and choosing which things to focus on. And so find the most high value opportunities to integrate and start small, sync what you need, select what you need, and yeah, let us know if you have any questions.
Thank you so much for coming to Appian World. Safe travels back home. Appreciate it.